Namaskar from the channel The Consultant's View. Today's technical topic is the challenges in implementing smart water management on an existing water supply system. In this era of water scarcity, mainly under urban settings, the water supply authorities have been trying their best to reduce the physical losses, primary water leakages in the water supply system which they are operating. It may be from the raw water intake to treatment plant transmission main, water distribution system, and even in consumer connection. Lot of researches, studies, piloting have been conducted. It is realized that identification of leakage is one of the major issue apart from many others. I repeat, identification of leakage point. It is evident that physical water losses, a simple example is leakage from pipe, will be there. There is no doubt about this. There may be theft also. The challenge is how efficiently the issue can be addressed and plug it as quickly as possible. One of the time-efficient ways is implementing of smart water management system. Simply, how smartly the system can be managed. There are many definitions of smart, and derived abbreviation is specific, measurable, achievable, relevant, and time-bound. In this specific context, I simply define it as the approach which takes least reaction time to get the solution done in an acceptable quality at an optimized cost. There are many factors which make it a challenging task to implement SWM and operate it effectively. Challenges get aggravated to multifold if it is on an existing system where the system is under operational condition. Let me discuss some challenges in implementing SWM on an existing water supply system. I was involved in such a project. I will extract a small section of that project, that is existing water transmission system, to illustrate the challenges. It was in the state of West Bengal in India. Requirement of SWM is basically to monitor the hydraulic parameters of the water transmission system from a remote location. By virtue of this, if there is any system malfunctionality, it can be easily addressed and analyzed. Based on the analysis, the problems and its location can be identified easily. The operators can reach that location to address the issue in minimum time. Some of the instruments traditionally used are flow meter, pressure meter, and level meter, and in few cases quality meter, water quality meter. Flow and pressure are monitored on pipe which primarily runs along the road below the ground, and level meter is installed in the reservoir within the premises of the operating authority. The fundamental behind this is to ensure uninterrupted flow of data from the instrument to the monitoring station at a remote location. What's that? Uninterrupted flow of data. It is the biggest challenge which I will discuss at the last. Before that, let me discuss other challenges associated with this activity. Customization of instrument. As per technical stipulation, the measuring instrument, that is flow meter in this case, needs to be installed at a certain distance from the valve center. The space available was not supporting to comply the stipulated specification. Side limitation was there, and there was no option other than to install the instrument within the existing valve chamber. The manufacturer was contacted, who did research on this. A correction factor was applied in the instrument to customize the specific condition. Installation of instrument in a congested place. One of the instrument location was in marketplace. It was quite a difficult task to install the instrument and ensure its security provision. I felt it would have been better to make information dissemination program before initiating this activity. It would have reduced the local issues. Security issue. Some instruments were installed on the main road. Security of the instruments from theft or damage became a major challenge. Necessary measures were taken, like providing security lock to the equipment and taking help of the local people. Power supply. The system requires continuous power supply, though a small voltage. As the site locations were predominantly in rural areas, ensuring continuous power supply was a challenge. We had to go for solar power in few cases. From this, the project had to incur additional costs inclusive of additional security. Dewatering of chamber, a big challenge it is. Few instruments were required to install within the valve chamber due to site constraint. The chamber was getting filled within an hour of pumping out. Working inside the valve chamber was a challenge. It was mainly due to minor leakages in the valve pipe fittings, and major was groundwater infiltration into the chamber. Local people queries. There was a wrong notion amongst the local that the authority will reduce water supply. Initially, they were not supporting the project. We involved community for their active participation. Information was disseminated to public and community about the project and convinced them how wise the project purpose was. Later, we got full support from the public. Coordination with operator. It may be considered as a challenge, though not so intense. The project activity needs to be synchronized with the existing schedule of operation and maintenance of water supply system. Now, let us come to the main challenge. What is that? Ensuring uninterrupted communication network. The system adopted was to transfer the data from the instrument to the monitoring station at remote location through text message. It was designed to be transferred through mobile SIM. Each instrument location, type of measuring parameter, time step, value data and other relevant informations were codified as unique entity. This data required to be get transferred to the remote monitoring stations at 2-minute interval. This raw data was then further decodified at monitoring station through software program and got analyzed. It was through an automation process which was developed by our team with joint effort of hydraulic engineer, software engineer and IT professionals. Selection of mobile SIM was an important factor. A recon was done at all sites to assess the mobile connectivity and the mobile connection company which gives service at different locations. Accordingly, the SIM was procured from one service provider for all instruments. As the data will be transferred through text message, the instrument procured was compatible to 2G connection. But inadvertently, the SIM procured was 4G Kolkata circle. All the instruments were located under West Bengal circle. The system was not working. There was no data transfer. In this context, let me say the network provider has one circle for state West Bengal and the other for Kolkata, the capital of West Bengal. We kept on trying to find out the cause of failure. The agency team, manufacturer team and an additional specialist dedicatedly assigned to fix this problem joined us. It took us a lot of time, more than a month, to figure out the root cause. Being the lead, I left no initiative, including trial and error. Finally, the youngest engineer in my team, hardly 4 years experience, passed out from IIT, got it solved. We changed all the SIM from 4G Kolkata to 2G West Bengal. Then it worked. On retrospective analysis, it was discovered that 4G SIM of Kolkata circle was not getting supported when installed for 2G activity in a location within the geography under West Bengal circle. It was a great learning and the biggest challenge we overcame. No book, guidebook, technical paper, no teacher, big shot elite class specialist and advisors has not made us to educate this. It was purely our virtuous effort and dedicated honest endeavor for negotiating specific site problems. I forgot to mention another major problem. The challenge was to find out the actual alignment of pipe under the ground on which the instruments needed to be installed. It was the second biggest challenge we faced. The pipe was laid 2 decades ago along the road shoulder by the water authority. At that point of time, GIS was not that popular, and pipe alignment detailed drawing data was absent. At later stage, the road was widened by the road department, which ultimately brought the pipeline alignment at the central position of the current road profile. It was not known to the department personnel currently involved in this operation. Neither to the local can say it. We were blindly carried out making trial pits, having no clue of the actual alignment. It was an old man from the locality who guided us on this and helped us to locate the present alignment of the pipe. On query, the old man said that he took the reference from an old banyan tree which was still there. It again validated the phrase, old wood best to burn, old wine to drink, old friends to trust, and old authors to read, by Greek philosopher and grammarian Athenias. That's all for today. Hope I am successful in giving a broad picture of the challenges. Hope you can now easily identify the risk involved in such a project activities. Okay, can you do a risk assessment on this? Let's try. It is your homework. I am there to help you out. Thanks to the viewers for being with us in participating in this channel. Thanks you again. See you soon.